Thank you for joining us for today's lesson. Good morning, good afternoon, good evening, depending on where you're watching us from, depending on the time of the day that you're going to access this particular presentation. Thank you for choosing Shifting Grades Online School. So we're going to discuss this great paper. It's good for you to know that Mokasa joint examination is done by 3 great schools. That is Moi Girls Eldoret, Moi Kabarak, and Sacho High School. So it's a great joint examination, a very well thought out paper which has been set by NEC examiners. And therefore, through the discussion of this paper, it's my hope that you guys are going to benefit and reap a lot from the discussion. Ladies and gentlemen, allow me mention something about our programs. We are having one-on-one NEC programs, and we're also having programs for the continuing students. So KGCSE and KCSE candidates are invited to register. Look at our number clearly presented there, 070415 3366. Reach out so that you may know much about our programs. But generally, we shall be starting on the 10th of August to the 21st of August 2026. This program shall be recurring in every year. So if you are a Form 3, if you are a grade 7, if you are a grade 8 learner, if you are in grade 10, this shall be recurring. Every August, we shall be preparing learners for the national examination. So please join us. The continuing students will still be having their program. Yeah, they will still be having their program. Very interactive, whereby they can ask questions, they will interact with the teachers fully. But for the NEC program with examiners, it's good for you to know that it will be a very serious showcase, whereby NEC examiners will be exposing the marking techniques, the prediction patterns, and everything that you need to know before you sit for the national examination. It's also good for me to mention that we are incorporating qualified counselors, psychotherapists, people that are going to take us through very serious and technical topics, very sensitive matters that are affecting our youths in schools. So we shall be hosting psychotherapists for guidance and counseling sessions, still within the same program. Actually, the timetable shall accommodate that. So you can use our number actually to inquire about the timetable, about the registration process, so that you may join us, so that you may polish your skills socially and academically. So please do not be left out. Do not be left out. This is the best. Find time and register for the interactive classes. Look at the poster, identify your program, and register accordingly. Now, this paper has been done, the section 1 of the paper. If you didn't find time, kindly scroll through our platform, Shifting Grades Online School, and access the presentation on paper 2, section 1, which is a very healthy paper. But now allow me go directly to the section 2 of this paper, number 17. Now, Kapsoya Senior School constructed a water tank in form of a cylinder with a base radius of 8.4 meters and height 10 meters. Part A determined the capacity of the tank in liters. All right. The first thing that we're doing here is the calculation of volume. Then now with volume, we shall be able to convert volume to capacity. Being a cylindrical tank, we know that volume in a cylindrical solid is given by cross-section area, which is circular, so pi r squared, multiplied by length or vertical height of the cylindrical object. So at this point now, ladies and gentlemen, we can perform what we call substitution now of every variable. pi 22/7, radius of the tank 8.4 meters. This one is supposed to be squared, multiplied by the vertical height of the tank, which is 10. So at this point, now we're getting 2217.6. meters cubed. But it's good for you to know that now that we're talking about capacity, then this has to be converted from cubic meters to liters. 1 cubic meter is equivalent to 1,000 liters, meaning that if the cubic meters are 2217.6, then the liters shall be, we multiply by 1,000 because each liter is equivalent to 1,000. Then we multiply this by 1,000. So it shall be, after multiplying by 1,000, it shall be 22176, then 2 zeros, liters. Now the volume has been computed. The capacity has been obtained after conversion. Part B, which is now on rates of work and proportions. Part B is saying that the tank is served by 2 inlet cylindrical pipes, A and B. Pipe A has a radius of 2.8 centimeters, and water flows through it at a speed of 10 meters per second, while B has a radius of 3.5 meters, 3.5 centimeters, and water flows through it at a speed of 12 meters per second. The reservoir is initially empty. Determine part 1, the amount of water in liters in the tank after 2 hours. So now, initially, this tank is empty. Then both pipes, A and B, are opened simultaneously. That's the assumption I'm making. After they've been mentioned, they are going to fill this particular tank at the respective rates. 10 meters per second, that is the water flow. 12 meters per second, that is the water flow. Then the question is, after 2 hours, so assuming that they shall now operate for 2 hours, what amounts of water shall have entered this particular tank? So we have to say, look at this. You know, there is the volume that comes out. There is the volume that comes out from a particular pipe within a second. Yeah, within a second. So within a second, water is moving. You know, there is a tube of flow in physics where we talk about the equation of continuity. At this point, you will allow me simplify the language to mathematics. Now, here is a pipe. Within this pipe, the inlet pipe, assuming this is pipe A, now we have a radius here, which is 2.8 centimeters. Then water is flowing from the pipe, meaning that within this pipe, water is moving at a speed of 10 meters per second. So water shall cover 10 meters within 1 second. So what amount of volume will have come out when the water will be flowing within such a length of 10 meters in 1 second? What amount of volume will have come out as the water flows in such a rate? So because we have this length of 10 meters where the water shall flow through in the pipe, and we have the radius here, then we can get cross-section area of the pipe and the length through which water shall flow in a second. So that gives us, that gives us the volume. Therefore, volume in a second from A in a second, volume of A in a second. Remember, it's good for you to know that pipe A is having a radius which is in centimeters. Therefore, I'm going to use pi R. Then I divide this by 100 to make it meters, and I will still be squaring the radius. Are we together in that? Then now times 10, which is the length. Look at that. I'm ensuring that the radius is converted to meters so that we get volume in meters cubed. So from pipe A, it's going to deliver within 1 second exactly 0.02464 meters power 3. So meters cubed. That is now the volume that shall come out of pipe A within a second. What about volume from tube B? The length of tube B through which water shall flow in a second is 12 meters. Within 1 second, inside tube B, water will flow 12 meters, meaning that within 12 meters, and the pipe having a radius of 3.5, then we can get volume again within a second. 3.5 should be divided by 100 to make it meters. Then we square the radius times length of 12. Therefore, we're having 0.0462 meters cubed. This is the volume within a second, pipe B. Allow me also talk about volume in a second. The amount of water that will enter this particular tank in a complete second from the two pipes now. So volume A, we add volume B. We add the two values, 0.0462, that is B, and A, 0.02464. We're getting a total volume from the two of them, 0.024. Okay, sorry, I'm adding, sorry. After adding the two values, we're supposed to get 0. When I compute this, 0.0462 plus 0.0264, and I add the two, I'm getting 0.07084 meters power 3. So this is the volume which is going to enter the tank in a second. Then we want 2 hours, ladies and gentlemen. We want 2 hours. How many seconds are in 2 hours? That is the first. Again, conversion of units. We're saying 1 second, the tank will receive from the two taps, from the two pipes, meters cubed. What about in 2 hours? 2 hours, we multiply by 60. That will give us minutes. Then each minute is also having 60 seconds. So we're going to get 7200 seconds. 7200 seconds. So what about 7200 seconds? What amount of volume shall be there? So if each second is having this volume, then 7200 seconds will have, when we multiply each second by the amount of volume per second. So we multiply and we shall get exactly, let me compute that, 0.07084. I multiply by 7200. I'm getting 510.048 meters power 3. This is now the volume that will have entered the tank within 2 hours, which are equivalent to 7200 seconds. After getting the volume, remember we're supposed to convert it now to capacity in liters, because we need now the amount of water which will have entered this particular tank. All right. So we convert this by multiplying it by 1,000. You remember the relation that we gave in the previous question? You're not supposed to multiply by 1,000 so that we get now capacity in liters. 5 10,000 and 48 liters of water will have entered this particular tank. A good question so far. Can we check part 2 of the same? Let us check part 2 of the same. We try to find the time it takes to fill the tank to the nearest minute. The time it takes to completely fill the tank. It's good for you to know that in the first place, we worked out the capacity of the tank. It is here. The capacity of the tank is 2,217,600. Then now the question is, if within 2 hours we are able to fill 510 and 48 liters, what about the whole tank? So we just ask yourself, are 510,048 liters will enter the tank within 2 hours. What about the total capacity, which is 217,600 liters? Is that well? Yeah, 217,600. That is now the total capacity. How long will it take? So it will be times 2. And 600, sorry. Out of 510,048. This now shall give us exactly 8 hours and 42 minutes. 2 times yeah, so we're getting 8 hours and 42 minutes. Can confirm that from your calculator. And because the parameters of time had not been made clear, then we can still operate with minutes. Total minutes, 522 minutes. So you can still work with minutes. You can still work with minutes. Part C. If an outlet cylinder or cylindrical pipe C has the radius of 4.2 centimeters and water flows through it at speed of 10 meters per second, calculate the time in hours it would have taken for an empty tank to fill up if all the pipes A, B, and C were all opened at the same time. Look at that. At the same time, we are opening the 3 taps, the 3 pipes. Can we check volume of C, of which now C is an outlet? Pi R, the radius is 4.2. We make it meters. Then we square the radius. And within a second, it shall flow 10 meters within the pipe. 10 meters within the pipe. Therefore, with the cross-section area, we should now multiply by the length. So that volume of a pipe C shall be 0.05544 meters power 3. So within 1 second, pipe C is going to empty this volume. So can we now talk about A, B, then we empty C. As A and B are filling, C is an outlet. So it's letting out. So we added the 2. They will let in 0.07084. That is what will enter the tank from A and B. But now C is coming in to empty 0.05544. So let me compute this for you first. Let me compute this 0.07 0.084 according to what the two are going to fill. Then we subtract 0.05544 and we're going to get 0.0154 meters power 3. So this is the volume which is going to be retained when A and B are filled and C as emptied. Then the net volume that remains in the tank is 0.0154, like that. So with this now, ladies and gentlemen, we can say that within a second, this is what the tank is going to receive. This is what the tank is going to receive. So can we say that 0.0154 meters power 3 is taking 1 second to enter the tank? What about the total volume of the tank? Actually, we can use the total volume at the level of total volume of the tank at the level of cubic centimeters here, cubic meters, that is 2217.6. What about the total? 2217.6 meters power 3. How many seconds will this take? 1 times 2217.6. Then we divide by 0.0154. How many seconds will be taken in this case? 2217.6 we divide by, so I'm getting 144,000 seconds. These are the seconds the tank is going to take to be fully filled. I hope we are flowing together so far. At the comparison level, you can convert these capacities to volumes, okay, these volumes to capacities, so that you use liters in 1 second, and the liters that were converted in the first question for the whole tank. But when you use the volume level, it's still the same. Remember these parameters, you can start dividing the seconds by 60 to get what? Minutes. But I'm telling you that you are already having, have we been told in hours? Calculate the time in hours. All right. In hours. So when we divide this by 60, we shall get 2400 minutes. Then now we can further divide by 60 so that we get exactly 40 hours. So the hours being taken now is exactly 40 hours. That remains now our final and only answer. Unlike the question here whereby we were told to find the time it takes to fill the tank to the nearest minute. To the nearest minute. So again, this is the final answer. That one is the final answer. So we're supposed to know that conversion of units is a very key concept. You can see we are in one question, we are converting within the parameters of time, seconds, minutes, hours. Within volume and capacity, there's also interconversion. So you're supposed to be very conversant with unit conversion. Are you okay with how number 17 has been handled? If yes, then type yes, I'm learning. For those that are joining us late, please be reminded of our very productive classes here via Google Meet. Please join us. Google Meet is a very interactive app whereby you are able to ask questions. You are able to raise up your hand when you don't understand, and the facilitator checks on your concern. So please do not be left out. This is the best opportunity, and more so for the candidates, whereby we are hosting NEC examiners. Kindly do not be left out. We are here to ensure that you succeed. Thank you so much for joining us, people, and thank you for choosing Shifting Grades Online School. As I mentioned earlier, we are incorporating guidance and counseling. We have a very serious team of psychotherapists. They are going to deal with handling peer pressure amongst teenagers and also finishing strong. That will much affect everybody because we are going to term 3, which is the last one, and you're going to make a legacy even as you crown the level of education that you are already handling. Just to give a further introduction of our programs, we have these holiday programs. They happen every holiday: April, August, November, December, still via Google Meet, so do not be left out. Then for the day scholar candidates, we have mentorship programs every week: KGCSE and KCSE Mathematics and KGCSE Integrated Science. Do not be left out. Our physical mentorship, that is for KGCSE and KCSE candidates within Nairobi. So if you're within Nairobi, you may use our number here to reach out and book a physical appointment so that we may mentor your son, we may mentor your group of learners, we may mentor your class, and all shall be well. So please reach out so that you may encounter our impactful, interactive, and transformative sessions. Number 18, the table below shows the values of x and some values of y for the function or for the curve y equals to x power 3 minus 7x plus 6 in the range -3 all the way to +3 for the values of x. So you can see, and some values of y, no, some values of y have not been provided in this table. So we can see values of x, then blank space for the values of y, meaning that we're going to do what we call substitution. Look at the first value of x. How do we get y? Y is given by x power 3. So we substitute -3 power 3. And look at the application of brackets. -7 into a -3, then +6. That is what you're supposed to do. Then you key into the calculator now, just as you've substituted, and this will give you exactly 0. The next, you go to -2, you substitute -2 instead of -3, you get exactly +12. I'll be saying something about this particular graph. A lot of remarks I'll be giving so that you may stay guided. -1, you substitute in the function where there is x, and you shall still get a 12. And there is a 0. When you substitute 0 in this function where there is x, y shall exactly become 6, because everything else here becomes a 0. So we shall get 6. Then at 1, you substitute 1 here. We're having -7. You substitute also 1 there. Then there's a 6 here, and everything becomes a 0. Then when you substitute 2 again, power 3, -7 into 2 plus 6, you shall still get a 0. And finally, when you substitute +3, you shall get 12. 2 marks for just substitution, basic skills in mathematics, where every learner can substitute and get the values of y. Graphical marks are the easiest to get. Again, the question continues in part B. On the grid provided, draw the graph of y equals to x power 3 minus 7x plus 6 for the range -3 x all the way to +3. So the values of x are ranging from +3 to -3, the limits included. The limits included even according to the table. So this is what we're going to plot. You can see already the scale has been chosen for you. The scale has already been chosen for you. So that's why no wonder instead of 3 marks, whereby we give marks for correct choice of scale, correct plotting, then a correct line or a curve. 3 marks. For this case, the examiner has already chosen a scale for you, meaning that if the scale has been chosen for you, then why are you going to be given the scale mark? There is no need, of course. So that's why the marks are 2. Plotting, then the curve. So let's now get to the plotting of these particular coordinates. Negative 3, 0. Negative 3, 0. The coordinate is there. At negative 2, we need 12. Negative 2, 12. Negative 2, 12. At negative 1, again 12. Negative 1, 12. At 0, positive 6. At 0, positive 6. At 0, positive 6 is here. That's going to be the y-intercept of the particular curve. At 1, 0. At 2, still a 0. At positive 3, 12. At positive 3, positive 12. The coordinates have properly been plotted. Now, what remains is joining these particular coordinates to come up with our curve. One thing that you're supposed to know, and also from what has been observed in the plotting, it's good for you to know that there is what we call turning points of curves. Turning points of a curve. The highest point in a curve. If you have a point turning like this, you see, at the highest level, we have only one curve. We have only one coordinate. Therefore, you're supposed to turn at that particular point and not any other. Not above it, not below it. But now, there are cases like what we have, whereby one time you shall turn, or one time you shall plot, and you discover that it is not a distinguished coordinate, which is at the topmost or bottommost. Remember, it can also be like this, whereby if the bottommost is only one, and you turn at that one, like that. But now, in our case, ladies and gentlemen, the maximum points and the minimum points are not clear. We have 2 points at the topmost point, and also in the bottommost points are 2, not one distinct point. Therefore, you don't turn at any of them. You don't turn below them if it is the maximum points, and you don't turn above them if it's the minimum points. You turn exactly between them. If it's 2 points at the topmost, like this one, you turn in between them. You only ensure that your curve is smooth, but you turn in between them. You don't make one of them a turning point. And if they are on the lower side, if they are minimum points, you also turn in between them. So you don't turn at a specific coordinate now. You turn in between them. So don't force a maximum point, which is not distinct. Don't force a minimum point, which is not distinct. So allow me now plot the curve by joining. Remember, I've told you that in our case, we don't have a specific maximum or minimum point. So we now join the curve. Look at this now. Yes, that's what I was talking about now. So you turn slightly above both of them. Slightly above both of them. Then here we come again. Slightly below both of them. Slightly below both of them. Sorry, slightly below both points. Yeah, like that. Then you continue flowing. Then you continue flowing. Remember, your curve should be smooth and continuous. Your curve should be smooth and continuous. So we are having the smooth curves. We are already having the smooth curve. That's why you are advised to use a pencil. That's why we will always advise you to use a pencil. Because one time you'll make a serious mistake in your curve, in your graph, then you discover that you used a permanent ink. Use a permanent ink, and you're using a permanent ink on a national examination paper, whereby you cannot tell your teacher to give you a full scarf to finish up with your work. What will you do in such a case? So now we have our outstanding curve here, very smooth. The curve is for the equation 1 equals to x power 3 minus 7x plus 6, like that. So we have our cubic curve properly plotted. Now with the curve like that, ladies and gentlemen, with the curve like that, we may now continue with other questions. Our curve is now solid. We can now continue with other questions. Part C of this great question. Now use your graph to estimate the roots of the following equations, of course. The following equations. It's good for you to know that this is equal to 0. Sorry, I think that's a typing error. It's an equation, yeah, equals to 0. So the equation looks exactly like the function that has been plotted. So what you do in a case like this, you subtract the two functions. The plotted one is y equals to x power 3, 7x, 6. The one to be solved, 0 equals to. So now you subtract corresponding terms, y minus 0. Then everything here simplifies to also give us a 0. X power 3 and x power 3, negative 7 and negative 7, 6 and 6, they all give a 0. So which line is y equals to 0? It is exactly the x-axis. Y equals to 0 is the x-axis. So where does the graph intersect? The graph intersect the x-axis. It is at points negative 3. When you look at this, the x-axis is here. So the x-axis intersects with the graph at negative 3. So the roots are negative 3. The roots again are positive 1. The roots again are positive 2. So we have those roots for the given equation. Then look at Roman 2, another equation. We still subtract the plotted function and the function to be solved. So our intention is to eliminate power 3 and get a linear graph. So to eliminate power 3, remember this is a x power 3, but this is negative x power 3. They are not alike. Therefore, instead of subtracting, this time round now we're supposed to add. When you add the two functions, it shall now be x power 3 plus negative x power 3, and they shall cancel out. In case you subtract, it shall become positive 2x power 3. So y plus a 0, it remains y. X cubed plus a negative x cubed, that becomes a 0. The negative 7 plus 8, that becomes a positive x. This is a 6 plus a negative 2. This becomes a positive 4. Yeah, that becomes a positive 4. You can come up with a small table of values to plot this. Or now that we know that this graph is having a y-intercept of 4 according to the equation, remember this? We are already having the y-intercept as 4. So we are sure that the curve the graph after the plotting shall pass through here. We're sure of that coordinate. And we also know that there is a gradient of 1. Then it means with one coordinate on the x, another coordinate on the y, we can have that coordinate again. So the graph can trace such an equation. Those can be suitable coordinates within the particular. But for the average learner, it's good for you to know that it's actually advisable. You know, you can follow the gradient to draw a line without having to compute coordinates, as long as you are sure of one coordinate, you can flow from that one. When x is a 0, and you substitute a 0 in this equation, y shall be 4. When x is 1, y shall be 4 plus 1, 5. When x is 2, y shall be 6, like that. So those are the coordinates. Those are the coordinates we should be having. And actually, applying my approach can mislead. The first one, I've discovered that along the y-axis, we don't have 1 unit per square. That's why I said 1 by 1 because of the gradient of 1. But now you see the vertical axis is having a very different scale. Very, very different scale. So now we can talk about 0, 4 and 2, 6. 2, 6 is a coordinate that will be at this point. So with those coordinates, okay, there's also 1, 5. So 1, 5. So at this, you can now do a straight line. Straight line. Straight line. We're also going to name that line according to its equation. Like that. So we have our straight line. We can name the straight line, which is a graph of the line y equals to x plus 4. Yeah. Y equals to x plus 4, like that. X plus 4. So we have our graph perfectly plotted. Now we check, where does this line interact with the graph? You read the coordinates, you read the values of x at the coordinates where the graph is intersecting with the line. So the first one shall be, this is before 3, but after 2.8. So this negative 2.9, the first intersection here, negative 2.9. Another value of x where the two graphs are intersecting at this point. When you look at the second intersection here, and you read that value keenly, it shall be negative 0, or positive, sorry, after 0, positive 0.3. Then finally, x equals to the other point of intersection. So this point, which is beyond 2.6, before 2.8, so we can talk of 2.7 positive. Remember, an error is usually allowed plus or minus 0.1 in such a scale, 0.1. So people with a negative 3.0, people with 0.4, people with 0.2, people with 2.7, 2.6, they might be considered, or they get considered for a mark. Not might be, they get considered for a mark. That is called a human error. So it's accommodated in geometry and graphical work. So that is part C of the question. Can we look at part D? Can we look at part D of this question? In part D, the examiner talks of, in part D, the examiner is talking about drawing a tangent. Estimate the gradient of the curve. Y equals to x power 3 minus 7x plus 6 at x equals to negative 2. At x equals to negative 2. So we draw a tangent at x equals to negative 2 on this particular curve. X equals to negative 2 on the curve. x equals to -2. -2 is here. So the point on the curve where x is -2 is at this point. So now we're supposed to do a curve. We are supposed to do a curve there. Remember, use a tangent. Sorry, we're supposed to do a tangent at that particular point. It's also good for people to know what a tangent is. A tangent is a line which touches a curve or a circle without passing through, just touching at a point. Touching at a point. Yeah, touching at a point. So at this point, if we are to draw a tangent, then we shall do a line which will simply touch the curve at that point, x equals to -2, without having to still curve, just touching it. This is a tangent now. That is a tangent to the curve. A tangent to the curve like that. So with that tangent now, we can proceed to find the gradient, whereby we can read coordinates along the tangent. Along this tangent, we can talk of the coordinate -2 itself, -2, 12, -2, 12, and also -4, 0, -4, sorry, -4, 6. This coordinate here, -4, 6. -4, 6 is another coordinate where the tangent is passing. So the gradient of a curve at a given point is equal to the gradient of the tangent to the curve at that particular point. That is the concept being applied here. That's called graphical work, rates of change, instantaneous rates of change. Therefore, 6 minus 12, that is change in y, out of change in x, -4 minus 2, -4 minus a -2. Yeah, 6 minus 12, then -4 minus a -2. So this shall be a -6, and this shall be a -2. The gradient is exactly +3. So the gradient is a +3. A very good question on graphical methods from 3 work. So thank you for following up with such a great question. We are in shifting grades. If you're learning something, please type, yes, I'm learning. Remember to reach out through 07 04 15 33 66. So that's our official line. You can use it. If you don't get us via a call, kindly consider it wise giving us a text on WhatsApp. It will really help us to coordinate. Number 19, ladies and gentlemen, we told that the figure below shows a model of a roof with a rectangular base, ABCD. Now, AB equals to DC and equal to 20 centimeters. Then BC equals to AD, that's 12. Those are the measurements of the rectangular base. The ridge PQ, you can see it's 8 centimeters top there, 8 centimeters. All right, and is centrally placed, centrally placed. When we talk about centrally placed, it means the far it is from AD is the same as the far it is from BC. So it's centrally placed. Calculate to 1 decimal place. Look at that instruction. The instruction now is every question is coming under this particular instruction. Special instructions about accuracies needed in a question. That is where majority of our students lose marks. They don't want to be very keen with details. Imagine out of 10 marks, and they have been broken into how many questions? 1, 2, 3, 4, 5. So 5 parts, assuming you know everything, you know every concept, but you didn't take serious to 1 DP. So you lose 1 mark from the separate 5 questions. That means you knew 10 marks, but at the end of the day, you shall go home with, you knew 10, but you go home with 5 because the question has been broken down and you didn't follow instructions. So let's get now to this diagram and the questions. The length of QN, the length QN. Look at QN. Any instructions about N? Yeah, N is the midpoint of BC. Yeah, sorry. Thank you. That is now seen. QN is the line through here. And I've been telling you that friends of three-dimensional geometry are Pythagoras theorem and the trigonometric ratios. Trigonometric ratios. Those are the friends of three-dimensional geometry. Right angled there, of course. This is a 6 and this is a 6. Since N is in between, N is a midpoint. It's already been instructed. N is the midpoint, so it's already instructed. So it goes without saying that now this becomes, that becomes a 6, 6. All right, some more interpretations. Some more interpretation is that, are we given the sloping sides? Are we given the sloping sides? No, we are not given the sloping sides. So we don't know the measurement of QC, but it can be found. Look at this. Look at this. I'm going to introduce another line here. And it's also good for you to know that these are equilateral triangles. Look at that statement, equilateral triangles. Meaning if BC was 12, what about this one? What about from Q to B? Equilateral, the interpretation of equilateral triangle. Okay, you can also interpret it otherwise by saying the angle at C is 60, or the angles are 60. So the angle here, 60 degrees, the one here, 60 degrees, the one here, 60 degrees. We can interpret it that way. I don't know now whether we are in agreement. So these are 60 degrees angles, 60 degrees, 60 degrees, 60 degrees there. 12, 12, 12 centimeters. So now with the 6 and 12, we can apply Pythagoras theorem. Yeah, and say 12 squared minus 6 squared, then the square root shall give us Qn. 12 squared minus 6 squared, getting the square root of 108. The square root of 108. But now to 2dp, we can't leave it as a sad. We have to compute and get 10.39, 10.39, which is equal to 10.4, according to the instructions of 1 decimal place. 10.4 centimeters like that. So we have 10.4. Which instruction have you used? Remember, I'm saying this, alternatively, we can apply the angle here. You say because of equilateral triangle, this goes without saying that it is 60 degrees. So with 60 degrees and 6 here, then 12, or even 6 alone, can we say that the tan of 60 degrees is given by opposite length, which is QN, out of the adjacent length, which is 6, meaning that to remain with QN shall be 6, the tan of 60. Then you compute using a calculator. 6 tan 60. 6 tan 60. I'm getting 10.392, which will still settle at 10.4 centimeters. Exactly the same. Exactly the same. So you can use any of those approaches for Roman 1. Can we check Roman 2, which is talking about vertical height of P from the base? P from the base. How long will be point B from the base? Look at this. That vertical height. This vertical height is what we need. Now, for that vertical height, vertical height, you know, we said that the ridge PQ is centrally placed. Being centrally placed, it means we'll have 8 centimeters at this point. We shall have 8 centimeters at that point. Now, with 8 centimeters, ladies and gentlemen, remember the total MN is equal to 20 centimeters because the base is rectangular. If AB is 20, then when you pass at the mid from M to N, it shall also be 20. So 8, from 20, we remain with 12. So the 12 can be split into 6 and 6. Yeah, to 6 and 6. Then one thing that you're supposed to know is that Q is as far as P from the base. So if we get the length at this point, it will still be the same. So now, bringing the interpretation to this side, we are already having 6 here from point T to N, that is 6. Then we are already having this measurement here. So I'm using an interior right angled triangle, which is already having the length here as the root of 108. Let me use the exact value. The root of 108, and we're having 6 on the base, so the vertical height can be obtained when we say the root of 108 squared minus 6 squared. Then we find square root. It shall give us x. So x shall be 108 minus 36, the root of 72. The square root of 72. Exact value, 8.485. Okay, this is exact value. Now we need the rounded off value according to the instruction. 8.485, but 1 dp, 1 decimal place according to instructions, it remains 8.5. 8.5. A very excellent question. 8.5. We are getting very significant lengths which are going to be used in computation of some angles. Yeah, computation of some angles. Can we proceed to part B now? Now, in part B, ladies and gentlemen, we're being told to find the angle between the planes ABCD and DCPQP. DCQP. DCQP and the base. DCQP, the sloping edge of the other side and the base. We know that for you to find an angle between two planes, you consider a line from one plane. You first identify where the planes meet, then perpendicular lines to the meeting edge. They make angles for each of the planes. What we mean with our case already, we are having a DCQP. I wanted to say DCP. Then I remembered we are not in a political rally. So look at this. We draw a line through DCQP. Then another line should also be drawn through the base ABC. Another line through ABC. So the angle now, the angle there will mean everything. Take to account that PQ is centrally placed. So we are actually using the angle at this point. Let me illustrate it in a better way. Okay. So we're supposed to know that we have made a right angled triangle there. And now we need the angle at this point. We need the angle at that point so that we may get the angle between the plane, DCQP, and the base. So this is equal to 6 centimeters. Remember the total was 12. Then vertically we have the root of 72. So we are having the square root of 72. We need the angle here. We have the square root of 72 and we have 6 here. So how can we get the angle at this point? How can we get the angle at that point? So the angle at that point can apply tan. Yeah, I think tangent will be one of the easiest ways of approaching. The tan of this angle will be given by opposite. Tan of this angle shall be given by opposite, which is the root of 72, out of the adjacent length, which is a 6. So to get the angle, we need the tan inverse, shift tan of what we are already having. So we can find this answer now, whereby you find the square root of 72. We divide it by 6, we get 1.4142. Then shift tan inverse 54.73. 54.73. 54.73, but we need 1 dp. So just 7 is okay. 54.7. 54.7, like that. A good question. Very, very good question. Part C. There's another angle here. There's another angle here to be done. We told that the angle between the planes ABQP and DCQP, I think those are the two sloping. ABQP sloping length, and also DCQP, also a sloping length. So we need to identify again where the two meet. They are meeting at the ridge PQ. So again, let me outline. So through the first plane, we do a line. Through the other one, we also do a line. So the angle we need is here. The angle between these two particular. Yeah, these two. So we need the angle at the top there between ABQP and DCQP. Where they meet, we have identified. So the angle in between there. So now we can work with this particular information now. Allow me call this one point T and this one point R, like that. Then up there, the apex, can call it Z, just using some alphabet. So RTZ, let me show you. We're now having RTZ. I'm now extracting that triangle. RTZ. Which measurements are given? The measurements given are from RT. If this is 12, then that's 12 because it's through the base. RT 12 centimeters. RT 12 centimeters. Look at that. 12 centimeters. Then what else is provided? The vertical height is known. Vertical height there is known. The vertical height is equivalent to the square root of 72. This one is equal to the square root of 72. I don't want to use rounded off values. Let me use the exact values. Square root of 72. Look at that. The square root of 72. Remember, the angle we need is the angle at Z. The angle at Z is what we need. Yeah. The angle we need is here. The whole of this. So we can now subdivide the two and have 6 here and 6 here. Then we work with a smaller angle here. Let me call it angle alpha. Let me get angle alpha. So with angle alpha, can we talk about tangent? The tan of alpha is given by opposite length out of adjacent length, the root of 72. Meaning that to get the angle alpha, we need the tan inverse. Shift tan, 6 out of 72, like that. So can we find this angle now? 6 divided by the square root of 72, 0.7071. Then now shift tangent, 35.26. Yeah, 264, that. But now the whole angle RZT, the whole angle there should be 35.26 multiplied by 2. So we have to multiply this angle by 2 now, so that we get 70.528, 70.528, but now to 1 dp, it becomes 70.5. That's a very critical question. Two planes that are both sloping and they are meeting along the edge or the ridge PQ. It's very technical to analyze that, and you're supposed to have followed keenly and understood what is happening. If you're getting something on 3-dimensional geometry, please type, yes, I'm learning. Our programs remain as planned. It's also good for you to know that these programs shall be recurring every holiday. April holiday, November, December holiday, August holiday will be the climax of everything, because that is the time we are preparing candidates for NEC assessments. So NEC program from the 10th to the 21st of August 2026 via Google Meet. So please do not be left out. This one shall be great. Do not be left out. Very interactive, and you shall get an opportunity. I know, okay, I know some of you are in national schools, very good schools, and you meet NEC examiners at the school level. But now it's good for you to know that there are learners who are not taught by NEC examiners, but now we are giving them an opportunity to interact with NEC facilitators. Please tap this opportunity and run with it. Please get this one and run with it. We're going to get a very serious showdown whereby our examiners are giving us very serious tips. Those who are following up with the Mokasa 2 joint examination, physics paper 2 presentation, you've already gotten at least a taste of what you're going to experience from Sanzioki of Moigal's Eldoret. And remember, is among the setters of Mokasa, the paper that we're discussing. So those are the levels that we are going. Those are the kind of people that we're going to partner with, together with very good other examiners in every learning area that I'm going to poach for you people. So count on the strategy that we are applying here. Count on our strategy. Count on our strategy. We are giving you the best. Do not be left out. KGSEA, you can be sure you are in safe hands. Team leaders, assistant chief examiners in NEC, we are acquiring them for you. So please do not be left out. Do not be left out. We shall give you the best. We shall give you the best. Use our number to consult more about our programs. Number 20, ladies and gentlemen, it's on sequences and series. An arithmetic progression, that's an AP, has the first term as A, the common difference as D. Write down the 3rd, the 9th, and the 25th terms of the progression in terms of A and D. In terms of A and D. We know very well that nth term or nth term in a nth term in an AP is given by first term A plus n minus 1 multiplied by the common difference. N minus 1 times common difference. So when we talk about the third, then it means the first term plus 3 minus 1. 3 is our n now, minus 1 into D. When we talk about the ninth term shall then be first term plus 9 minus 1 into D, 8D. In terms of A and D, that is the instruction. Then the 25th shall be A plus 25 minus 1 multiplied by the value of D. So we are having now the terms already put down as unknowns. Expressions for every unknown. So already clearly and wonderfully outlined. The next part of this. Now the AP is increasing. That means that instruction alone is very sensitive. D is increasing. It's a positive value because the progression is increasing. From one term to the next, we get a bigger program. So a bigger value. So it is not a decreasing one. Decreasing one will have the common difference being a negative. Okay. So now we are told that the third, the ninth, and the 25th terms, the ones we've listed above, form the first three consecutive terms of a geometric series. If the sum of the seventh term and twice the sixth term of the AP, is 78, calculate the first term and the common difference of the AP. Calculate the value of A, value of B. The sum of the seventh term, seventh term shall be A plus 6D. That is the seventh term. And twice, underline sum, seventh term, and twice the sixth term. We are adding twice the sixth. Sixth will have a 6 minus 1 times D like that, equals to 78. That is our one of the equations. Can we continue simplifying this? A plus 6D plus 2A plus 10D, I've opened the bracket there, equals to 78. Grouping of terms together will give us a 3A plus 16D being equal to 78. We can have this one as equation 1 and leave it unsimplified like that. Then we get to the first statement that the third, the ninth, and the 25th form the first three consecutive terms of a GP. Now, to form the first three consecutive terms means that we're supposed to interpret now the knowledge with a different progression in our head. In our mind, you should have a GP now and say, this term and this one, they now consecutive in a GP, meaning that, ladies and gentlemen, we're supposed to say in a GP there is a common ratio. What's a common ratio? A GP can be 2, 6, 18, meaning that we are multiplying by a certain factor. 2 times 3, we get 6. 6 times 3, we get 18. 10 times 3, we get 54, like that. So if they are consecutive, it means then the ratio can be gotten by, when we pick 6 and we divide by 2, we should get the same as 18 divided by the previous term, the same as 54 out of the previous term. So we can see there is a common ratio of R. Therefore, with the same idea of what a GP is, then we can say, when we pick the ninth, which now is second, because we've been told they are consecutive. When we pick A plus 8D and we divide by the first part, which is a plus 2d, we should get the same as when we pick this third term. Our 25th now becomes third because they are consecutive. A plus 24d, and you divide by a plus 8d. So we can now simplify this equation by cross multiplication. With the cross multiplication, ladies and gentlemen, with the cross multiplication, we shall have a plus 8d being multiplied by a plus 8d, meaning that we just square that part, equals to a plus 2d multiplied by a plus 24d cross multiplication. When you square this, we shall have a squared plus 16ad plus 64d squared equals to, we multiply a times everything in the second bracket, the normal opening of brackets. A multiplied by everything in this bracket, get a squared plus 24ad. Then we multiply, we add, continue adding. 2d should also multiply everything in the second bracket. 2d by a, we get 2ad plus 2d by 24, 48d squared. At this point, we can group terms together. A squared and a squared shall cancel out. Then 16ad and 24ad, we can group them together. Let me bring them to the right-hand side. So 24 minus 16, get 8ad. What about 64d squared and 48? I'm getting 16d squared. At this point, we can divide through, we can make it as simple as possible, but this is our second equation and it's not simplified. Can we divide by d so that we get 8a being equal to 16d? Look at that. What about the value of a? Get the value of a as 2d. The value of a equals to 2d, like that. So the value of a is 2d. If the value of a is 2d, I've divided by a. Okay, to remain with a, I've divided by 8. So that 16d becomes 2d. Now that a is 2d, this can be our most simplified expression 2. Then with that, we get to Roman 1 now, equation 1, and substitute 3a. Instead of 3a, we write it as 3, and instead of a, we use 2d. I'm rewriting equation 1 plus 16d equals to 78. Plus 16d equals to 78. That's after substitution. So 5d plus 16d, 6d plus 16d. Is that true? Yeah, 6d, 16d equals to 78. This is a 22d equals to 78. I'm looking at that equation very carefully to see whether somebody could be making a mistake in the grouping of terms. In the grouping of terms, as we try to find the value of d. Could there be a mistake somewhere? I'm looking at the equation very carefully. I'm looking at the equation very, very carefully. So I'm having 78 being divided by 22. I'm getting 3.5 something. I am sure we are supposed to get a very rational answer. So allow me to check my grouping of terms at that point. Once again, I recheck my my grouping of terms afresh. We are already having the first equation very okay. I've tried to check the terms there. What about in the cross multiplication of the second one? Cross multiplication of the second one. A squared, 24AD. We didn't add here. 24AD and 2AD. 24AD and 2AD, that one we didn't add. So I only considered 24AD alone. I forgot there is this 2AD. So back to that. Sorry. Or man is to error. Man is to. Sorry for that inconveniencing step. Okay. We said A squared and A squared, that one cancels out. But 16AD, we are already having 24AD and 2AD. That is 26AD. What about minus 16AD? It becomes 10AD. Then here, 64 minus 48. So 64 minus 48, it becomes 16D squared. It's like that, yeah, sure. It's now like this. So we'll be talking about now, to remain with A, we can first have 10A, divide by D throughout, 16D. Then to remain with A itself, comes 1.6, the value of D, because we divide by 10. So the value of A in terms of D should be 1.6D. So with that now, ladies and gentlemen, with that, we need to talk about is being our second equation. Then we group terms together. Grouping of terms together. Okay, solving the two equations simultaneously means we can use substitution. Instead of 3A plus 16D, we can have 3, and instead of A, 1.6D plus 16D, 78. So this is a 4.8, 4.8D, 16D, 78. 20.8D. 20.8D equals to 78. So how will you remain with D? You have to divide by 20.8, 3.75. I knew the answer is a terminating decimal. That's why I didn't settle for the answer that I had gotten. Then now we can get back to the value of A, which is given by 1.6, the value of D. So the value of A shall be by 1.6, I'm getting exactly 6. Yeah, like that. So we have the value of A, we have the value of D. Value of A and D have been worked out. Find the sum of the first 9 terms of the AP. For the AP, we have a first term and common difference. Do you remember that sum of a given number of terms is given by n over 2 into 2A plus n minus 1 into D. Yeah, like that. So this shall then be given by sum of first 9 terms. So 9 out of 2 into 2 by the first term. The first term is a 6, eh? So 6 plus n minus 1 times D. 3.75. This is 4.5 into 12 plus 8 multiplied by, 9 minus 1 is 8 multiplied by 3.75. This is exactly 30 plus 12, 42 by 42 now. This is equal to exactly 189. Exactly 189. It's good for students to have opportunities, and it's good for them to have what you call alternatives. When you're working a question like this, you can think of sum of a given number of terms being given by n over 2 into a plus l. A plus l is the first term and the last term. The last term is here. Here is the ninth term. L in our case is the ninth term. Now, according to the formula of nth term, which is described here, the ninth term shall be what? Ninth term shall be a plus n minus 1 multiplied by d. So this shall be 6 plus, is it 30? Yeah, 36. So seventh term is 36. So the sum of the first 9 terms shall be n over 2. So 9 itself over 2. 9 over 2 into a is the first term and L is the last term. This is 4.5. This is 42. And this is the same answer. So you can use that alternative working, that sum of a given number of terms in an AP. In an AP, it's given by n over 2, n over 2 into first term plus the last term. A very great question. Very, very good question. This one is a brainstormer. Yeah, a brain teaser. You must think when working out this one. And you can see that it has been brought to you in the best approach possible. The best approach possible. The best approach possible. So that is it, number 20. We are proceeding with the work. Thank you for remaining here. Remember to type on the comment section. Let us know where you're learning from. Let us know your school. Let us know whether you're getting something from our presentations. Remember, please, to subscribe to this platform. Remember to share so that you may invite your great friends. And also remember to enroll to our great programs here. A NEC program, ladies and gentlemen. We are having the best, and we are the best. We are having the best, and we are the best. Is that okay? We are having the best, and we are the best. So please reach out. From the 10th of August to the 21st of August, 2026, that is when we shall start our programs. The continuing students, those who are not waiting for the KGCEA and the KCC this year, we shall have them properly occupied by our team of teachers who are ready to help you. So please do not be left out. Please do not be left out. This is the best. Use our number to consult. Proceeding to number 21. Yeah, number 21, which is a very good question. We're being told that the figure below shows part of the curve whose equation is given by y equals to 6 minus x plus 2, and the line y equals to mx plus c. The line is given very general equation. Very, very general equation. We can see the general equation of the curve and general equation of the line and the specific equation of the curve. Part A, find the coordinates of the points A and B. point A and B. You can see point A and B. Those are the X and Y intercepts, or Y and X intercepts of the curve and also the line, respectively. They meet at the same points. Yeah, they are meeting at the same points. So can we say that point A, at point A, which is a y-intercept, the values of X are 0. Yeah, it's a y-intercept. So the values of X are 0. At A, the values of X are 0. So we use the equation of the curve because it is given. So y equals to 6 minus 0 into 0 plus 2. So this is going to be 6 times 2. Yeah, we get 6 here and get 2 here. So y will be 12 at such a coordinate, meaning that the coordinate of A shall now be given by, now that y is 12 and x is a 0 data point, then it is going to be, it's going to be 0, 12. What about the coordinate of B? B is the x-intercept. B is the x-intercept. So we can all agree that at point B, which is an x-intercept, the values of y are 0. Along the x-intercept, values of y are 0. So 0 equals to x plus 2. We can use this one as we can use it as a simplified quadratic expression. A simplified quadratic expression, whereby we will now say if this factor and this one multiplied give us 0, then both of them, or at least one, is equal to 0. So it's either 6 minus x equals to 0 or x plus 2 equal to 0. So to remain with the 6, we have x becoming positive, or to remain with x, we have 2 becoming negative on the right-hand side. So we have two possible values of x, 6 and negative 2. Technically and logically, when you look at the intercept, whereby at B, the value of x is lying on the x-axis. Lying on the x-axis, you can see it is on the positive side. The y-axis is here, this is on the positive side. So it can't be a negative, and it is on the right-hand side of the y-axis. So it's a definitely. Now we settle for x equals to 6. We settle for x equals to 6 because logically, when you observe where B has been plotted, it cannot be having a negative coordinate of x. Therefore, now that we know the value of x, B will have a coordinate of 6, 0. Those are the coordinates for point A and B. Wonderful question. Very wonderful. Very wonderful question. Okay, looking at part B of this good question. Part B of this question. Determine the equation of the straight line y equals to mx plus c. The coordinate. Can we first find a gradient? Can we first find gradient? We can find gradient m, which is given by, you know, the line is also passing through the points A and B. It's having them as their intercepts. So can we say this? That we did change in y coordinate 12 minus 0 over change in x, 0 minus 6. This is 12 over negative 6. This is going to be negative 2. So our gradient is a negative 2. With a gradient and 2 coordinates, can we express equation? I'll start with that concept so that we may all first understand. Then I show you another technical approach to the same question. Check here. After getting negative 2 as our gradient, can we say that now gradient is given by change in y? We use the general equation xy and one of the provided, like y minus 12 out of x minus 0. See, x minus 0 remains the way it is. So y minus 12 equals to Cross multiply negative 2x. That other one is a 0. So to remain with y, we are having negative 2x, and also 12 becomes positive on the right-hand side. Positive on the right-hand side. That is the equation of the line in the said format. In a very quick way, I can show you a different approach. Once you found a different approach to this working for the equation, once we've been told that the line should be in the form y equals to mx plus c, we know that this is the value of gradients, and we know very well that it is the value of the y-intercept. Now, if you are aware of that, then you can directly express the equation y equals to the gradient x, the y-intercept. Where is the y-intercept? At point A, whereby we discovered the value of y there is a 12. So if you have the y-intercept and you have the gradient, then the equation can be fixed without any working. The equation can just be fixed without working a lot. Anyway, it's 2 marks, and we have already computed gradient. So what's wrong with just expressing our equation? Very simple. Very, very simple. Very easy to understand. Yeah, but see. Find the area between the curve and the line. Area between the curve and the line. The line and the curve. In simpler terms, okay, remember this is a 0 and this is a 6. It's good to remember that. In simpler terms, we're being taught to find the shaded area. The shaded area. We are told to find the shaded area, like that, the shaded area. So we can now get to the question and see. The shaded area is in between curve and line. So we can first find the area between the curve and x equals to 0, all the way to x equals to, from between the curve and the line here, y-axis, x-axis, yeah, and also x equals to 6, x equals to 0. Within this range, the whole curve and anything between it. So we can find first area between curve, y-axis, x-axis, then again from x equals to 0 and x equals to 6. The whole area, the whole area, the whole area from point A through the curve to B through the x-axis and up to A again. The whole of this area to be found by integrating this curve. So we integrate the curve within those limits. From 0 to 6, we're integrating 6 minus x plus 2 with respect to x. It's good to know that we're supposed to expand the curve first. So let's have the expanded curve. 6 times everything in the second bracket. Negative x times everything in the second bracket. 6x plus 12 minus x squared minus 2x. Any terms to be grouped? Yeah, the x's. So y shall be equal to negative x squared plus 4x plus 12. 6 minus 2. Yeah, 6 minus 2. After the expansion, 6 minus 2 is a 4. So negative x squared for x. We are now expanding. Negative x squared 4x 12 with respect to x. It's after the expansion now. We can perform the integration now. We can perform the integration. The power of x here increases by 1, making it x power 3. Then the new power should divide the whole term like that, plus the power of x, which is power 1, becomes power 2. It increases by 1. Then the 2 divides everything. So x power 2, and you'll be having 4, everything divided by 4. By 2, the new power, that is. Everything should be divided by the new power. Plus 12. X is to power 0 here. So it becomes now x power 1, or rather x is now reduced. Remember, it's a definite integral. So we don't really have to include the arbitrary constant c. We don't have to, since it's a definite integral. We substitute 6, negative 6 power 3. Negative, actually it is a 6 which is to power 3 out of 3 plus, okay, 4 over 2 became 2. So 6 is now squared. 12 into 6. Then we subtract the same function when we substitute 0. Because there is a term of x in everything, there is x in everything there, then we simply get a 0 when you substitute 0. So what's going to be found here? 6 power 3. We divide it by 3, getting negative 72. Getting negative 72. Then I add 2 into 6 squared. Then I add again 12 into 6. I'm getting exactly 72. Exactly, I'm getting 72 square units. That's after substitution. This is the area under the curve. Area under the curve from 0 to 6. What about area below the line? Area below the line. Area below this line shall be given by, remember from 0 to A, we said A is 12. So there are 12 units. From 0 to 6, 6 units. So we can treat the unshaded area as a triangle first, and have half base times a perpendicular height of 12, which is again going to give us 36. 72 over 2, 36 square units. At that point, area again below the line, we can integrate this particular line from 0 to 6. Integrate the line from 0 to 6. So we can integrate our straight line from 0 to 6. Straight line equation is y was equal to what? Negative 2x plus 12. Negative 2x plus 12. This is with respect to x. So the power of x improves, increases to 2. So negative x squared. Because after increasing to power 2, it divides everything again. So the 2 divides plus 12 into x. X is now reintroduced during integration. 0 to 6. So this area now shall be, look at this. We substitute negative 6 squared. Then we shall have plus 12 into 6. This is negative 36 plus 72. 36 square units. So you can use either integration or you treat the area below the line as a simple triangle. It's a simple triangle. In both cases, you're getting 36. Now with that, we can talk about the shaded now. Shaded is now between the curve and the line, meaning that we need the original 72 area below the whole curve minus area below the line, giving us 36. Square units. 36 square units. 36 square units. A very good question. Very, very good question on integration. Very good question on integration. Very good question on integration and its applications in computation of area. In computation of area. A good one. A very, very good one. You're learning something? Type yes, I'm learning. I will not even mind knowing the name of my follower, the school they come from. Yeah, show your interest in mathematics. Show your pride to the school that you come from. Let's know where you're following us from. I'm checking your comments, of course, and feel highly regarded. We value our followers. Remember, Shifting Grades is beyond 96,000 subscribers. Beyond 96,000 subscribers. And now, this time round, ladies and gentlemen, we are targeting the Silver Creator Award. The Silver Creator Award is given or awarded at the first 100,000 subscribers. And I'm looking up to you people so that through your referrals, through your subscriptions, we may attain, through the referrals, we may attain the Silver Creator Award. 22. A jet flies from Q, 60 South, 24 East, to town R, 60 South, 10 West, and then due north for 1200 nautical miles to town S. Determine the latitude of S. All right, allow me begin by doing a sketch of this information. What is happening in this particular flight? What are we doing in this flight? We can have our prime meridian and our equator like that. This time around, we're using the southern hemisphere, where we're saying that is 60 south. These were the two places lie, the first ones. Q is to the east. And where on the east? 24 degrees in the east. So the intersection of 24 degrees in the east and south in the north, it gives us our town Q. And where is P? Or not P, where is R? Still 60. On the south, 10 in the west. 10 in the west. 10 degrees west. So the intersection of 10 west and 60 in the south gives us our town R, like that. Therefore, a pattern is being followed here. The jet is flying from Q, then due north. So from Q to R, it's now going to race upwards, northwards. To where? To S. Where is S? 12 degrees nautical, 12 nautical miles, 1200 nautical miles. So we're supposed to understand now the motion is changing. It's going to flow along 10 degrees west, which means it's moving along a great circle. So this is distance along a great circle. Distance along a great circle and in nautical miles, ladies and gentlemen, is given by 60 times theta. In this case, theta is latitude difference. Latitude difference. Now, if that is latitude difference, ladies and gentlemen, it can be identified. 1200, 60 by unknown data. We can remain with data. We divide through by 60. 1200 over 60, ladies and gentlemen. I'm getting 20 degrees. Therefore, when this particular jet is flying from R, it covers 20 degrees towards the north. Remember, already R is at 60 on the south. Therefore, when you cover 20, even if you are going to the north, you shall still be on the southern hemisphere since, look at that, since, southern hemisphere, since you've not covered more than 60. When you cover more than 60, that is when you shall penetrate the northern hemisphere. You shall go now beyond the equator. You shall go beyond the equator and join the northern hemisphere. But as long as you are covering an angle difference below 60, you shall still be on the south. Therefore, we say angle difference is given by when places are on the same hemisphere. Places on the same hemisphere. You subtract the two latitudes. So 60 minus the latitude of S, which is unknown, the latitude of S, which is unknown, should give us our theta. So to get the theta, which is our latitude, to get our latitude now, 20 should be subtracted, 40 degrees, and it's on the south. So actually the naming of latitude should be very specific. You can't just say 40. The south is more important. Equally important is the value of 40. So 40 in the south, 40 in the south. It's good for you to agree. It's good for you to agree that this thing is well explained. Look at what I'm saying. We are still at 40 south. That's why from 40 to 60, there is now the angle difference of 20. I hope you get that. Okay? Okay, are we together? Type yes, I'm learning. Comment sections. Calculate the distance between Q and R, first in nautical miles and 2 in kilometers. We computing now distance from Q to R, from Q to R. And actually, we are assuming that it's along now the parallel latitude. So along parallel latitude, it's good to know that circles of latitudes are small circles. So distance in nautical miles along a small circle is given by 60 times the angle difference, cosine of the latitude. In this case, alpha is the longitude difference. Longitude difference. When you're moving along a latitude, you encounter longitude difference. Longitude difference. So with this understanding now, what will be our longitude difference? We're moving from 24 in the east all the way to 10 in the west. Look at that. So from the axis of the earth, 24 and 10. So the whole of this angle now between Q and R. The whole of that angle shall be 24 in the east, 10 in the west, giving us exactly 34 degrees. So now our distance from Q to R shall be 60 multiplied by 34, cosine of the latitude where the two places are. So cosine of 60. And when you compute this from your calculator, ladies and gentlemen, you get a distance of 1020 nautical miles. 1020 nautical, 1020 nautical miles. A very good question. Part 2 of the same question. Part 2 of the same question, we're talking of the same distance, but in kilometers. Distance, now in kilometers, is usually given by the longitude difference out of 360, 2 pi r, cosine of the latitude of the two places. So 34, 360, 2 pi R is the radius of the Earth. It has been provided. 370 cosine of the latitude. So cosine of 60. 60 is the latitude where the two places are lying. So you compute this, and if we are to give it to the accurate value, we can do a decimal, we can do a fraction, sorry, 1890 and 7/9 kilometers. 7/9 kilometers. It's good for you to know that you can use a decimal, but ensure an accuracy of more than 4SF. Yeah, an accuracy of more than 4SF. A very good question. Can we check part C of the same question, ladies and gentlemen? Find the total flight time if the jet flies at an average speed of 800 knots. 800 knots means 800 nautical miles in every hour. That's the meaning of knots. So we're going to use the distance which is in nautical miles. Total distance covered in the whole flight. Total distance covered during the flight. Total distance during the flight shall be equal to total distance during the flight shall exactly be equal to what? We check the first distance and we use the one in nautical miles. Sorry, I've said, yeah, I've emphasized we consider nautical miles now. So total distance in nautical miles will be very specific. First, we're having 1020. And initially we had 1200 nautical miles. So we've gotten this one from Q to R, 1020. And from R to S, we were given that it was 1200. So the two distances can be added up now. You use your calculator wisely to get 2220. Total distance of 2220 nautical miles. With total distance and we have speed, we can find time. Time is given by distance out of speed. So 2 out of a speed of 800. This is giving us, excuse me, 2.7, sorry, hours. Yeah. So the fraction of hours can also be converted. This is 2 hours, 46 minutes. Any of this will attract the final. Any of this will attract the final mark. So that's how serious the question was on longitudes and latitudes. Longitudes and latitudes, a very wonderful question. You get something, type yes, I'm learning. And remember, ladies and gentlemen, there is a full video. I saw somebody asking for longitudes and latitudes. On our channel, Shifting Grades Online School, there is a very serious presentation on longitudes and latitudes. You can find time and scroll through our channel. You'll find topic-based presentations. Topic-based presentations, properly handled. And that is going to help you definitely. So do not be left out. Do not be left out. Do not be stuck. Ensure that you are consulting as you pursue your serious education. As you pursue your serious education. As you pursue your serious education. You can also use our number to enroll for our classes. The best out of the best. Please join and reap the benefits of being a follower of Shifting Grades Online School. Now, the probability that it rains on a certain day. This is a question on probability number 23. Yeah? We're almost finishing. This is our second last question. The probability that it rains on a certain day is 0.8. If it rains, the probability that a school bus will be stuck in traffic jam, 0.7, but otherwise it is 0.4. So the school bus can still be stuck in the traffic jam even if it didn't rain at a probability of 0.4. If the bus is stuck in the jam, the probability of students using the bus to arrive late is 0.3. Meaning that they can still use the bus and fail to be late. But when the bus is not stuck, we are not told any information about whether students will be late or not. Part A, draw a tree diagram to represent this information. Use letters R, J, and L to represent the events of rain, jam, and late, respectively. So they have chosen the letters of the alphabet that you're going to apply. On a certain day, it may rain or rain not. So we're talking of probability having rain or probability no rain. If the probability of raining is 0.8, the not raining, because the two are what you call mutually exclusive events, the two probabilities should be added to give us one. Mutually exclusive events. Probability of one excludes the occurrence of the other. The two of them cannot occur. We cannot have rains and no rains at the same time. So the probabilities of such events should be equal to 0. Should be equal to 0. Is that okay? Yeah, we proceed. We proceed. We also told that if it rains, the probability that the school bus will be stuck 0.7. If it rains, there can be jam or no jam. That there will be jam is 0.7, meaning that no jam 0.3. But otherwise, that is now if it doesn't rain. Being stuck in the jam is 0.4. Jam, no jam, 0.4, meaning that we shall have a 0.6 on this other side. A very good question. And finally, the final statement that should be interpreted is if the bus is stuck in the jam, the probability of students using the bus to arrive late is 0.3. You are on the jam, so you may arrive late or not late. Arriving late, 0.3. Meaning not late, 0.7. In the jam, can arrive late or not late. Late, 0.3, so not late, 0.7. That is now the tree diagram. Part B, determine the probability that it rains, the bus isn't held in the jam, but the students arrive late. Probability that it rains, look at that, raining. So we need probability raining, no jam, yet the students arrive late. So this is going to be raining 0.8, no jam 0.3, arriving late 0.7. Wait. Arriving late. If the bus is stuck, in the jam, look at that. If the bus is stuck in the jam, the probability of students using the bus to arrive late is 0.3. To arrive late is 0.3. So if there is no jam, we're not taught about the lateness or no lateness of the students. So kindly allow me suspend this question. then I do a consultation on the same. I think there's a typing error in this one. But the students arrive late. So we don't have lateness or no lateness when there is no jam. That one is not communicated. So let's check Roman 2. The probability that students arrive in school on time. Arriving in school on time means probability, it rains. Look at this. Probability that it rains, there was a jam and they came late. There was a jam and they didn't come late. Or probability, it rained, there was a jam and they came late. Okay, they didn't come late, sorry. Arriving on time, eh? So raining, 0.8. When it rains, jam, 0.7. Then arriving on time, 0.7. 0.7. Arriving on time, 0.7. Or meaning addition in probability. It didn't rain. There was no jam, 0.4. That there was jam, 0.4. But the students were not late. Not late. Look at that. They were not late, yeah. We need the options that they were not late. So when you compute and add this, let me get the two different probabilities, 0.8, 0.7, 0.7, getting 0.392 and 0.2 by 0.4 by 0.7, getting 0.056. When you add up, we shall be getting 0.448. 0.448. A good question. Good question on probability. Roman 2 of the same question. The probability that the students arrive in school late. Arrive in school late. So we identify the cases of late now. It can be, it rained, there was a jam, so they lated, or probability, it didn't rain, there was a jam, so they came late. Those are the only possibilities with the lateness. So raining, 0.8, jam, 0.7, and arriving late, 0.3. Arriving late due to jam, 0.8, 0.3, or probability it didn't rain, there was jam. When it didn't rain, there was jam, 0.4. And for that reason, they came late, 0.3, due to jam, 0.3, like that. So we can compute this now, 0.8 by 0.7 by 0.3, 0.168 plus 0.2 multiplied by 0.4 multiplied by 0.3. This is 0.024. We add this and I'm getting 0.192 as the probability in such a case. A good question again. Can we check part 4 of this? The probability that the bus is held in the jam. Held in the jam. Probability, it rains, then the bus is in the jam. Or probability, it didn't rain. Not there can be jam, even when it didn't rain. So raining, 0.8, and jam when it rains, 0.7. Or it didn't rain, and there was still jam. It didn't rain and there was still jam, 0.4. 0.4. Like that. So those are the possibilities. 0.8 times 0.7. This is 0.56 plus 0.2 multiplied by 0.8. This is 0.16. When you add, ladies and gentlemen, 0.72. 0.72. That's a good question on probability. Very, very good question on probability. Probability. It's my hope that it didn't rain and there was jam. It didn't rain, but there was jam, the 0.4. It didn't rain, there was jam, 0.4. It was held in jam, 0.4. It didn't rain, there was 0.4. So this is 0.08, giving us 0.64. 0.64, like that. 0.64. That is the question on probability. A good one, ladies and gentlemen. Very, very good question. I've said, you pardon me for Roman 1. I am not really understanding what that part means. The probability that it rains, the bus is not held in the jam, but the students arrive late. So probabilities of lateness or not late, when there isn't jam, is not communicated. That is why this branch ended at this point. We didn't proceed. And also here, we didn't proceed. So that is it. That is it. I like that. Number 24, which is on linear programming. A good question. Linear programming. Our programs are purely online. One time we shall have a mathematics rally. I hope you will not have completed the grade 12. If you're in Form 4, bye-bye, all the best. Please come, we prepare online for KCSE. But the people in Form 3, the time I'm speaking out this, the people in Form 3, the people in grade 10, the people in grade 9, the people in grade 8, the people in grade 7, backwards, they are likely to experience very wonderful programs as time goes by. So keep trusting, continue praying for us, continue encouraging us by enrolling to our programs. And I'm sure very soon we shall have serious programs in Shifting Grades Online School. We might have a one-day mathematics rally with mathematics talks, motivations, and everything until we work on your attitude. Yeah, we shall work on your attitude until you are there. So your success is our pride, and that remains my objective. A road contractor has to transport 240 tons of hardcore. He will use two types of lorries, type A, type B, all right? You'll see that. Then he has three types of type A, three type A lorries and two type B lorries. The capacity of each type A is 8 tons, while the capacity of type B is 15 tons. All type A lorries must each make the same number of trips. Similarly, all type B lorries must each make the same number of trips. The number of trips made by each type B should be less than twice those made by each type A lorry. Each type A lorry must not make more than 6 trips. Must not make more than 6 trips. Okay, part A. Taking X to represent the number of trips made by type A and Y to represent the number of trips made by each type B lorry. Form all the inequalities in X and Y to represent this information. You can start with the last statements here. Each type A must not make more than 6 trips. And remember, type A is making X trips. Therefore, for type A, the X trips must not make more than, so should either be 6 or less than that. That's one inequality. Again, we told that the number of trips made by each type B should be less than twice those made by type A. So type B is making and should not be less than, read that, strictly less than twice those made by. So it should be less than twice the ones made by type A. So type A is making a X. So Y should be less than twice the number of trips of type A, which is X. Look at that. I hope we are together in interpreting the last 2 sentences so far. The last 2 sentences. We should be together in that. The last 2 sentences. The last 2 sentences. What are we saying? That the number of trips made by each type B, that is why the number of Y trips should be less than twice the number of trips made by each type A. Therefore, the number of trips made type A are X. So Y should be less than twice X. Less than twice X. Then again, we should be able to coordinate this statement now. We are having 3 type A lorries, 2 type B lorries. The capacity of each type A is 8. So how many tons will be carried by type A? 3 times 8 is 24. 3 lorries, each 8 tons. 24 times the number of trips. Then 2 type B lorries with a capacity of 15. So 2 times 15 tons, that is 30. How many trips? Y trips. Now this will give us the total tons. And this particular contractor is supposed to transport 240. Look at the statement. He has to transport 2. So it's a must 240, which means what will be transported should be either 240 or above. So this is equal to or greater than 240. Equal to or greater than 240. 6 is common. Is it 6? Yeah, 6 is common. So we can simplify it to 4 by 6 again. This is the third inequality, which can also be this one. It's just a simplified form of the same. So we have our inequalities now properly plotted, properly outlined, properly formed. So those are the inequalities from the provided statements. Then in part B, the question is saying, on the grid provided, draw all the inequalities and shed unwanted region. Draw all the inequalities and shade unwanted region. Use 1 centimeter to represent 1 unit on each of the axes. Use 1 centimeter to represent 1 unit on each axis. So scale has been provided again. That means the simplifying of the equations is very key. Very key, since we are going to use a very small scale of 1 centimeter for 1 unit on each of the axes. On each of the axis. This is the X axis. Here is the vertical axis or the Y axis. Now we are using a scale of 1 unit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Such a thing. Can even label up to 11. Then on the other side, we can have 1, 2, 3, 4, 5, 6, 7. This 8, 9, 10, like that. So we have our graph. We have our graph like that. Let me zoom until you can see the axis now. The width have been labeled. Then we now plot our inequalities. Let me manipulate this space. We know very well that for every inequality, there is a corresponding borderline. So for the first one, it shall be x equals to 6, and it's a complete line, a full line. So x equals to 6. On the x-axis, where there is 6, we draw a vertical line. X equals to 6, and it's a full line. X equals to 6, like that, a full line. What about the second one? The second one, y equals to 2x, and it's going to be a dotted line, an incomplete line, a dotted line. So this incomplete line now, we need values of x and values of y, 0, 1, 2, those are enough coordinates. So can we talk about let's look at it well. Can we talk about when x equals to 0, what is y? Y equals to 2 times 0. When x equals to 1, 2 times 1. When x equals to 2, 2 times 2. 2 by the value of x, eh? So we're getting 0, 0, 1, 2, 2, 4. 0, 0, 1, 2, 2, 4. The line should pass at coordinates like those, and we said it's a dotted line. It's an incomplete line, so we can use a different shade here. The incomplete line. It is passing through the origin. It's passing through the origin. It's a dotted line. Yeah, these are the tips that you're supposed to be having. It's good to let lines intersect where possible. Yeah, like that. At this point, we can check the other inequality, which is now the last one. The last inequality is here, the simplified one. You can also work with x, y, 0, and 0. I use the intercept now. Let me prefer the intercepts. When x is 0, what shall be y? When x is 0, this part becomes 0. The whole of this part becomes a 0. So 5y equals to 40. And y will be 8. What about when y is 0? It is this part now to become a 0. Then 4y equals to? Yeah. 4y equals to 40, meaning that 4x equals to 40. So x is 10 when y is 0. So y-intercept 8. Y-intercept 8. X-intercept 10. Then we do our line. We do our straight line. We're giving you the skills to come up with straight lines in a very easy and convenient manner. Very easy and convenient manner. So we are connecting the intercepts now. When you prefer the intercept, you get a line very quickly. You said it's a complete line, right? It's a complete line. It's a complete line. Complete line, like that. So we have drawn them. We can see that there is a common region shielded by all of them. So after identifying the common region shielded by all of them, then you can now shed the outer sides of these borderlines now. can shade the outer lines of this bow, the outer sides of the border lines. Remember, you don't have to draw a line, then you start identifying where to shade. You draw another one, you identify where to shade. It will take you long. Just draw all of them first. Draw all of them first. Draw all of them first. We said it's a complete line, right? Yeah. Then, after drawing all of them now, identify the region that has been shielded by all of them. Then, after that, you shield the outer sides or identify where to shield depending on the instruction. Sometimes you'll be told to shield the region itself. So this is our region R. That's our required region. Properly plotted. Properly plotted. With that now, ladies and gentlemen, with such a plotting, we can check part C of the question. Determine determine, or we can check the instruction first. The cost of operating each type A lorry is 5,000 per trip, while that of operating type B is 12,500 per trip. Roman 1, determine the number of trips each type of lorry should make in order to minimize the cost of transporting the ADCO. Okay, we're going to identify a coordinate, which is going to give us the minimum cost. Some other times you'll be told maximum profit. You'll be told profits realized, but now we need minimum. Identifying the minimum or the maximum is called maximization. In maximization, we're going to use, there are several methods. You can use the search line. Yeah, you can use the search line. You can also use the inspection method, whereby you identify each possible combination of the two types that will give us a minimum, maximum. So here, when you are identifying possible values should be within the required region, in the region R, or on complete lines. Complete lines. When a line is dotted, it cannot contain a possible value. So lines should be complete. So we check values. Then for maximum or minimum, I'm giving you serious tips here. It's good for you to focus on the corners of the region. The corners of the region. The corners of the region. Now, the corner that we have here is made by a dotted line. So the top corner here, we eliminate it. Now, the corner at the lowest point here is not having a complete coordinate. Therefore, we also eliminate it. Even though they are complete lines, the corner is made by, it's not at a specific number of specific coordinate, a definite coordinate. So definite coordinates now can be read. Definite coordinates can now be read either inside the region or along any complete line. Within the region, we have these possible combinations. All these are possible. Remember, you're not supposed to pick points along a dotted line. It should be within the region. Those are the ones within the region. Those are the ones within the region. Then, apart from that, you now identify others along the green line. We have a point there. So it's along the green line. Again, along the vertical line, we can also identify points. We can also identify points. So we can compare which one will give us minimum. you can use rough workspace to try all the possible combinations. Because when you use this one, the coordinate is a 5, 9. You check the expenses there. You get 2. Well, this one is a 5, 8. 5, 8 is another one. Of course, it's now cheaper. You can also check 5, 7, 5, 6, 5, 5, and also 5, 4. You can check all those. So 5, 4, also check 5, 7, 5, 6, all of them. So 5, 4 here, of course, now will be the minimum when you compare all that. Remember, there is a 4, 6. Remember, there is 4, 6 as a possible combination. You can also compare it. There is also 4, 7, which cannot be having a minimum budget compared to 4, 6. So you see there's 4, 6, there's 5, 4 now. Then you can see also along the vertical line, we have a 6, 4 here, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11 actually. 6, 11 is a possible combination. All of those. So you check which one will give you minimum, which one is going to give you minimum. So when you compute all of them, you discover that the minimum is being gotten. Actually, it's like you get the answer here before this one. They should have told that and hence find. So 5, 4 shall be the minimum. 5 for type X, which is type A, and 4 from Y, which is costing. So actually, we should look for the least Y coordinate. From all this, the least Y coordinate should help us. Because Y is the most expensive, they should be the fewest then. Yeah, Y is the most expensive, so they should be the fewest. So 4 type B and 5 type A becomes the answer there. So that the profit itself now becomes the value we're getting here. Plus 12,500. So we can compute these. Then I show you another method of working out the same 75,000 Kenya shillings. 75,000 Kenya shillings. Now, the reason why I settled on the combination 5, 4 is because there's something called a search line. Search line. So we start by objective function. We first identify objective function. Objective function. Objective function is going to be given by 5,000 times the X type, 12,500 times the Y type to give us a certain value. If this is the objective function, then we can work on a search line. A search line will have a y-intercept, which is equal to the coefficient of x in the objective function, and an x-intercept, which is equal to the value of y on the objective function. Like that. So we can now simplify these values concurrently. We are having a 50 after dividing by 100, 125. What about by 25 again? We've divided by 100. Divide by 100 first. By 100, we got this. What about when you divide by 25, which looks common now? 25 dividing 50 will give us 2. 25, that's now the simplified y-intercept. Then 125 divided by 25 also shall give us 5. X-intercept at 5. So we simplify the two values up to 2 and 5. 2 and 5. 2 and 5. So y-intercept of 2, x-intercept of 5. Y-intercept of 2, then x-intercept of 5. This is going to give us such line. The such line, I can use a conspicuous color like this yellow. Let me see. Are we able to see it? Oh, this one is more conspicuous. I need something that can be identified even by a blind person. So let me use this particular color. That's yellow, yeah. 5 and 2 are the intercepts. So I draw this one. This is now called the such line. This one now, this one is the such line. That is the such line. Now with a such line, how to apply a such line is to ensure that you slide using a set square. You first support your set square with a ruler. Then you slide it. You slide the set square such that the such line is parallel. You are sliding the set square with the longer line being parallel to the such line. Such like it's like you are going to slide the such line itself now into the region. Now, as you enter the region, the first, you see at this point now, the first coordinate to come across is my 5, 4. 5, 4 is the first line to first coordinate to come across. So the first coordinate you will come across gives you what you call minimum. So minimum will be given by coordinate 5, 4. 5 on the x, 4 on the y. That gives us the minimum. Then if the examiner had asked about maximum, it will be, actually minimum is the first possible coordinate. So when you slide the set square, the first possible coordinate that you encounter gives us minimum profit, minimum expenditures. But now for maximum is given by the last possible coordinate that you come across using the such line. The last possible. The last possible would have been if you continue sliding the set square into the region, you would slide until you discover that the last coordinate you will go across is this one, the coordinate here, which is 6, 11. 6, 11. So for maximum expenditure would have been 6, 11. This will give us maximum. But now for minimum, the first one that we shall encounter, the first one to be encountered should be a fixed coordinate, a definite coordinate that you can read well. And this particular definite coordinate should be lying on a complete line or within the required region. So you can't identify it on the dotted line that we have here. It can't be there. It should be either on the green or the red. That's how you're supposed to handle linear programming. Thank you so much for following. Remember to subscribe. Remember to share so that you may invite more friends to Shifting Grades Online School, the home of academics. Use our number written on the board or described on this poster so that you may enroll to our serious programs. Thank you so much. See you in our next presentation. Bye-bye.